The following questions, question 29 to 31. Your first task is to find the perpendicular height. Your second task is to find the area of a parallelogram. The area of a parallelogram is base multiplied by height. It's in your notes. What was the most common made mistake I told you yesterday? Huh? People use the slant height. A lot of people will come up and say that's 20 times 17. It's not the answer. We need to figure out what h is. It's the distance between the two parallel lines is what we're looking for. Okay? So with that in mind, what we're going to do is we're going to do Pythagoras' theorem, where we're going to say 17 squared equals 8 squared plus h squared. 289 equals 64 plus h squared. Take 64 away from 289, you get 225 equals h squared. I'm pretty sure that makes h equal to 15. Okay? Now you know that h is 15. The base is 20. The perpendicular height is 15. Results in an answer of 300 centimeters squared. Okay, so that's question 31, 29 and 30 being the same thing. Now, in question 36, we have roughly 3 right angled triangles. It says calculate the distance q to t. Q to t being this distance here, very easy. Just say 5 squared equals 4 squared plus x squared. Then you'll get 25 equals 16 plus x squared. X squared equals 9. X will equal 3 when you square root it. So that's 3. What about part 2 then? QR, where's QR? QR is up here, we'll call that y. We'll say root 97 squared equals 4 squared plus y squared. 97 equals 16 plus y squared. This means y squared must be 81, y must be 9. So that makes that distance there 9. What's r to t then? R gone all the way down to t? 12. Because it's 9 plus 3, which is 12. And finally the last one, which is 12. We now have to figure out what is this distance here. We'll call it z. And this time around, it's just Pythagoras' theorem 3 times. It's actually very easy. Z squared equals 12 squared plus 5 squared. Z squared equals 144 plus 25. Z squared equals 169. Z equals 13. Okay, we're good to go? Okay. Okay, it's very easy. We have to calculate this height here. Can anybody just tell me how to do it really quickly? There's probably no need to hang around too much. Get the length of this one using Pythagoras' theorem. Get the length of x. Get the length of y using Pythagoras' theorem as well. Then x minus y is h. It's very easy. I only really need to stop there. Now, where they might get you is on a 3D problem like so. Okay? Now, just want to, in this question here, okay, it says PQ is 9, QV is 12, WV is 5. Find Q to W. So Q to W, I'm going to draw it in 2 dimensions. So Q to W is, would everybody agree W phi Q is right angled? Would you agree with that? Yeah. W phi Q is right angled. It's basically a box and it's right angled. Okay? So I write it down as a W phi to Q. I say that's right angled. I say that's 5. I say that's 12. And I'm going to figure out what that is. Is that alright? X squared equals 5 squared plus 12 squared. Okay? And that means x squared equals 169. Square root that. X equals 13. We alright with that? Good, good. Okay, now P to V. Everybody see P to V? Now, if you're really sewn in on, this is the diagonal I was talking about. This is the diagonal triangle, okay? So, if I, just need a different colour there. Okay, if I do it like this, that's what I'm looking at there. And that is in fact a right angle triangle. Because this has got, it's like, as I said, it's like me linking this part here to this part down here. You go along the bottom, straight up, and then diagonally across. So I'm going to draw that triangle now. Okay, and it's this one here. And we know that, we know W to B is 5. We don't know P to B, do we? And we don't know P to W. So, if I only have one side and I have no information, that technically means I actually chose the wrong triangle on this one. I'm going to use it for part 3 now, but I'm definitely not going to use it for part 2 because I only have one piece of information. Can't do anything with that, so I'm just going to store that there to the side. Going to come back here and I'm going to look up another one. Is there another triangle that contains PV? What about on the bottom? Somebody told me. So what about this green triangle here? Yeah? It's like the bottom of your book and you're just cutting across and down. Like that. Okay? So what we're going to get is DPQ. Where's the right angle located? At Q. That's 9 and that's 12. I'm going to do Pythagoras' theorem to find out what PV is. Once again, I might call it X or A or whatever letter comes into my mind. A squared equals 9 squared plus 12 squared. I think that's going to turn into A squared equals 225 and A equals 15. Now this 15 represents the length from P to D, which in turn turns this into 15.
Which inner triangle are we using again?
This one is the green one.
Okay, yeah.
So this one is the green triangle.
Yeah.
And the one on the right is the red one.
Okay.
That's the diagonal triangle I was trying to explain earlier.
Yeah.
Okay, now what I'd say will happen next is we're going to do Pythagoras' theorem one more time. And we'll call this B, such that B equals, B squared equals 5 squared plus 15 squared. B equals, that's 25 plus 225, which is 250. What's the square root of 250, anybody? Five root 10 or 15.81. Okie dokie. Now, I'm gonna stop there for a minute. Okay, see this one here? I'm gonna